The topic that I had choose is the determination of 1 naphthol and 2 naphthol in urine sample based on magnetic solid phase extraction. The toxic chemicals analyzed in this study are 1 naphthol and 2 naphthol. 1 naphthol and 2 naphthol are the derivatives of naphthalene, which is an organic material that is commonly used as a raw materials in pesticides, dyes, drugs, and insecticides. Naphthalene can lead to liver and nervous system damage, cataracts, retinal hemorrhage, and somatic self-hemolytic enhancement. International Cancer Research Institute had also classified naphthalene as a potential carcinogen in animals and humans due to its toxicity. Apart from that, 1 naphthol and 2 naphthol have been specified as biomarkers for naphthalene exposure in urine. Thus, it is crucial to have a reliable method in determining the content of naphthals in urine sample. Solid phase extraction method is the best method that can produce high recovery and high sensitivity of naphthals detection in urine sample. By using an improved SPE technique, which is called magnet solid phase extraction, these toxic materials can be extracted using a magnet graphitized carbon black. Separation of 1 naphthol and 2 naphthol from urine sample by selectively partitioning the naphthals between a solid phase and a liquid phase.
MSPE used magnetizable material as sorbent, where it is directly dispersed into sample solution without packing the sorbent into the cartridge. The principles of extraction method in MSPE describes as: in this study, the graphitized carbon black was grounded with iron oxide, a magnetic nanoparticles, in order to produce a magnetic graphitized carbon black. During the graining process, the iron oxide nanoparticles were physically wrapped and added to the graphitized carbon black, which then leads to formation of magnetic composites that can be easily separated from solutions using a magnet. The magnetic graphitized carbon black acts as MSPE adsorbent during separation and advancement of naphthals from urine sample. When the magnetic graphitized carbon black passed through urine solution sample, the naphthals were selectively retained on the magnetic graphitized carbon black through hydrophobic and pi-to-pi interaction, while other matrix of urine retained in the solution. Lastly, by coupling with high-performance liquid chromatography ultraviolet detection, a rapid and convenient method for the analysis of naphthals in urine matrix was established. Next, let's watch the video for the pre-treatment of the urine sample. Moving on to sample extraction procedure. Firstly, 20 mg of magnetic graphitized carbon black was placed into a 15 ml glass vial. Then, the solution was activated with 2 ml acetone by 2-minute vortex. Next, 10 ml of diluted urine sample solution was added and vortexed vigorously for 6 minutes to form a homogeneous dispersion solution. During this process, naphthals were adsorbed on the magnetic graphitized carbon black through hydrophobic and pi-to-pi interaction. Then, naphthals adsorbed magnetic graphitized carbon black separated rapidly from the solution using an external magnet. The supernatant layer was discarded while the sorbent gathered at the bottom of the vial. After washing the sorbent gathered with 1 milliliter of pure water, naphthals were dissolved from magnetic graphitized carbon black with 0.8 milliliter acetone at 6-minute vortex. The desorption solution was then separated from magnetic graphitized carbon black using a magnet and evaporated to dry under a mild nitrogen stream at 40 Celsius. Lastly, the residue was then dissolved in 100 microliter of mobile phase and 10 microliter of the final solution was supplied to HPLC UV analysis. The summary of the results obtained from the article. First,
all of the investigated urine samples were found to contain a certain amount of 2-naphthol, and all the urine samples collected from the workers are found to contain 1-naphthol. There was no interference at the retention time of 1-naphthol and 2-naphthol, showing that the well absorption of magnetic graphitized carbon black towards naphthols, and the presence of other urine matrix did not interfere with the retention time of naphthols. The results confirmed that the proposed method was suitable for quantification of naphthols from urine samples without the interference from other compounds. Let's look at the advantages of MSPE.
Magnet solid phase extraction is very beneficial as this enhancement increases the extraction efficiency and improves the mass transfer of analytes compared to solid phase extraction that needs much more delicate steps such as packing of sorbent materials into cartridge and column conditioning. Moreover, the sorbent can be easily isolated from the sample matrix using a magnet at the end of extraction, avoiding centrifugation for extractant collecting, thus reduce the pre-treatment time. Next, this developed method was convenient and rapid as the whole procedure of MSPE could be completed within 15 minutes. This method showed a great potential in sample preparation. Additionally, comparison with liquid-liquid microextraction, high toxic chlorinated reagent was not involved, which enhances the simplicity of operation. This method free from organic solvent and environmental friendly, where preparation of adsorbent only conducted in a mortar. Next, the amount of magnetic graphitized carbon black used in this method was obviously less than used in solid phase extraction due to the relatively high surface area of graphitized carbon black. Thus, MSPE increased the interact area between the sorbent and sample solution. Lastly, the magnetic graphitized carbon black can be used for the extraction of other hydrophobic analytes from urine samples.